Hi, everyone. This is Catherine from AI Dynamics. You might have formerly known us as Dimensional Mechanics, but we're coming to you with our very first video blog, or otherwise known as vlog. I'm with our CTO, Ryan Monsurate, and we wanted to just kind of connect since we're all stuck at home, see what he's up to, see what he's working on, because I know Ryan is on the front line with a lot of our customers and working on some really cool prototypes. So I selfishly want to hear about them, but figured we'd share them with the world. But before we get started, how about you introduce yourself, Ryan, and tell us what you've been up to maybe before you came to us as our CTO, and what got you excited about AI and AI dynamics more specifically.
All right. Hey, my name's Ryan Monsurate. I've worked in a number of different tech companies and industries, everything from AI to quantum computing and blockchain. And before they were buzzwords and not because they were buzzwords, I've genuinely been interested in technology and my entire life, ever since I started reading hard sci-fi as a preteen. I guess I got into the Foundation series at around 12 or 13, the same time I started teaching myself how to code. And I've kind of been in love with technology and the promise that it holds for our future ever since. So uh, my interest in AI has stemmed from obviously from science fiction, and AI has been a subject that's been in and out of favor for decades now. You know, we went through an AI winter, and then deep learning was this massive breakthrough, partially as a result of improvements to algorithms, some of the basic algorithms involved with neural networks, and then also partially as a result of the advances in computational power that we have available to us now. And so it became, we started going from a period where we had a decade of almost no real change in neural networks to 1 or 2 years where it seems like a decade happened. And I've been, yeah, I feel like we like to talk about the fear of singularity, or the promise of the singularity, or fear of machine learning becoming like the Terminator, or becoming like
Mm.
this AI that emulates human beings. Not only are we a long ways off from that, I don't think it's something we should necessarily be concerned about right now. And I think there's a lot of opportunity to use machine learning algorithms to revolutionize a lot of different industries. And what I really liked about AI Dynamics was it's not trying to solve that blue sky problem of building a thinking AI mind or a brain in a box. It's actually saying, what are the machine learning algorithms that have been developed by researchers all over the world, and how can we help users put them to use in their businesses or personally as quickly and as easily as possible. Like, you don't need to learn to be an engineer in order to use machine learning if you can use our software. And I think that is incredibly valuable because it helps democratize this technology.
Absolutely, absolutely, and that's why I'm here too. I love that we're making it accessible. The future's bright, and I think AI is going to be everywhere. But it's really cool some of the use cases that we have already put into place. So talk to me about that. I know you're working with a number of our customers and working on some prototypes, and we're helping them deploy our AI. So talk to me about, I don't know, what you did last week or what you're working on that you're excited about.
Yeah, I mean, we're working on a lot of different initiatives with different customers, everything from supercomputing to RNA to drug development and manufacturing systems. One of the projects that I was working on last week was for a very large Korean manufacturing firm that probably everyone's heard of and aware of. And they've got a product that is out in the field and deployed, and they send technicians out to go and service these industrial products from time to time. And what they're finding is that because these products are so complex and there's so many different parts, it's hard for these service technicians sometimes to understand, for that model number, what part they're even looking at that's broken down and what needs replacement. And so they've asked us if we could help them design a solution that could reside on, say, the service technician's phone. So they could take a picture of this complex machinery or all of these components out in the field, and they could identify all of the components that they're looking at, so that if they can point out the part that's broken, they can press a few buttons on their phone and order it right away. And our platform is ideal for solving this problem because there's very little coding involved. They would really just need to, and this is what we're working with them on, provide us lots of different labeled images that have to do with the parts that are in these machines. And then with about 20 to 30 lines of code on our system, we can create a model that they can deploy to the cloud. So we're going to work with them to deploy this to AWS so that they can start having this machine learning model working on identifying parts in the field in a matter of weeks, if not days. And then once that's up and running, our platform is going to roll out to not just cloud, but on-premise and also right to the edge. So running locally on a cell phone, if that cell phone has either a GPU that can do the matrix operations fast enough, or if it has ideally a neural processing unit or neuromorphic chip, which things like the iPhone and the Pixel have. And so you can envision a time in the future where even without a high-speed internet connection, or if they're underground or out of a service area, their phone could do the processing locally and identify everything that they're looking at on the phone without having to go to the cloud, without latency, and with a very lightweight model. And the advantage of, again, NeoPulse is you'd be able to build all of that using our software without having to write much or any code at all.
Wow. So put that into perspective for me, because I know you said 30 to 40 lines of code, and you said between 2 and 3 weeks.
Right.
Without NeoPulse, or if you were, starting from scratch,
Right.
what would that look like?
So you'd want to work with an off-the-shelf machine learning library. So you'd probably use Python and TensorFlow or Keras. You'd write a lot of code for your data processing and pre-processing to get it in the right state. And then you'd go read the literature on what types of CNN networks, or other types of vision networks, or maybe even non-neural network algorithms would be best for processing this kind of information. So then you'd select 2 or 3 or 4 or more different machine learning models that you think are going to perform well. You'd test each. You'd write a lot of code to train models from all of these different architectures, test them all out, find the one that works best, and then take that architecture and then tweak it and refine it and do hyperparameter tuning. Now you have tools like AutoML and hyperparameter optimization that can do some of these things automatically for you. So it's not like it's all done by hand, but there are a lot of those steps that you would be doing manually that take weeks to write, honestly. So you're looking at a start to finish project time of a few months versus a few weeks with NeoPulse.
Wow, that's huge. And hopefully one day somebody like me can do it.
Well, so our vision for the product long term, and we're working on it right now. We have a beta of the graphical user interface that's in deployment internally, and we're testing it out with some of our customers. But the goal long term is for everybody to be able to create and deploy machine learning models. Everyone from high school students to domain experts in every single field. So we want a drag and drop interface. You're going to be able to drag your data in, drag a few blocks in, connect them up with some lines, and then click go, and it'll build a machine learning model for you. And you really won't have to know very much more than the types of data that you're dealing with, what they look like. And we'll have the software kind of encode all of this machine learning and statistics expertise that usually a statistician or a machine learning researcher would have in their head, to be able to look at the problem and tell you how you need to modify, change the data, how the distribution of the data might affect solving this problem. All of that will be built into our software. So that is coming down the line.
I love it. So you're telling me that an enterprise can deploy AI across marketing and sales, and not just maybe sit with engineering at some point. So that.
Yes, I mean, we see a future in which machine learning becomes ubiquitous. So it's going to be just like software. I mean, we run apps on our laptops and our cell phones. There's software running in the cloud. Software's all around us. Mark Andreessen said software is eating the world. AI software is going to eat software. I mean, in a lot of ways, a lot of people are referring to it as software 2.0, which is a somewhat apt term. I mean, it is in many ways software 2.0. I think there's always going to be a hybrid of fixed function and machine learning algorithms working together. It's not going to be like machine learning completely replaces the traditional software, but just that analogy works because you will have machine learning models working in marketing, in supply chain, in inventory, in forecasting, and quality control. So you can imagine a world where, for now, these um, service people are going out and using our software to identify these parts that are broken. That could feed into another machine learning model instead of a traditional regression model that can determine when and why these failures are occurring, and could pull, for example, log data from the machines to say, these types of operations or these types of workloads are causing these parts to fail more often than not. And then you can also identify which types of workloads are associated with which customer segments. So now you've got a machine learning model that'll predict that for a new customer coming in the door that wants to buy a piece of machinery, their workloads are likely to look like these other customers that they belong to the same segment as. So we want to sell them this model of machinery. And we know from these service people that these are the parts that fail most often. So let's put more time in engineering into making those parts more failure tolerant or failure resistant. And on the assembly line, you can get as granular as taking, we've had a project where we literally put a microphone on the factory floor and listened to a machine operate. And we were able to predict with very high accuracy when the machine was about to fail a half an hour before it failed, just by listening to the
Whoa.
sound of the machine, because there's patterns in the sound of the machine makes. And so you can imagine, while we could have a CCTV camera looking at these parts rolling off the assembly line and doing a visual inspection like a human would currently do, there's all these other sensors on the factory floor that could feed data into a machine learning model that'll pick up on patterns that we didn't even know to look for in the past.
Wow.
The factories themselves will truly become intelligent.
I love it. The future's bright. Let's hope our future doesn't still involve us being stuck in our homes.
Yeah, well,
but
yeah.
but since we are, exactly, let's talk about, with any of your small free time, which it sounds like you're incredibly busy. But when you're taking a break from chatting with our customers and deploying NeoPulse in these crazy cool ways, what are you doing stuck at home? And what should we know? What show should we binge? What games are you playing? How are you connecting with the outside world?
Let's see. I just finished season 3 of Westworld, which I thought was okay. I haven't caught up to Rick and Morty yet, which just came out, so I'm looking forward to that. That's in my queue. And recently been playing a little bit of Creed VR, which is like a virtual boxing game.
Ah,
Yeah, I'm really excited about the future that the future promise VR holds. It's going to be great.
that's cool.
Yeah,
Is it a solid workout?
it is. Yeah, you'd get more of a workout than you'd expect out of it after 20 minutes in there,
Okay,
even if
I
it's
like
just
it.
shadow boxing. Yeah.
Nice. Awesome. Well, thank you, Ryan. Really appreciate you taking time to talk with me. Hopefully, we'll be doing this on a monthly basis, again from our homes, but hopefully, I can see your face in person sooner rather
Yeah.
than later, too. But we're certainly staying home and staying safe. So, thank you for your time, and I appreciate it.
Thank you so much for having me.